In this section, we're going to learn our first method for solving systems. Remember, systems are equations where you've got two equations. They have x and y in them. That means they're linear. And we're going to solve the system, and you have to find an ordered pair answer. So we're always looking for an x and a y. So we'll be solving for either x or y, but we can't forget we've got to go back and find the other values. Now with substitution, so there are two different ways. We're going to learn substitution right now. In substitution, what you do is you take one of the equations and you solve it for one of the variables. It does not matter whether you solve for x or whether you solve for y, but the key is to look for a 1x or a 1y, because you don't want to have fractions in these to have to worry about solving. So look for a 1x or a 1y. Then once we solve one of our equations for either x or y, we're going to take what we have on the right side of the equation and we're going to substitute it into the second equation for that variable. Then we'll solve for the variable and then we'll go back and plug in. It's much easier to kind of do these than it is to sit here and listen to me explain it. So this is what happens. Look at number 1. We've got y equals 13 minus 3x, and then 9y plus 2x equals negative 8. Okay, on this particular one, this first equation is already solved for y, so step 1's already done for me. So what I like to do is I like to box that in, and I'm going to take that 13 minus 3x and I'm going to substitute it in the bottom equation for y, because y equals 13 minus 3x. So then I'm going to come over here and I'm going to rewrite, replacing my y with 13 minus 3x, and then we have plus 2x equals negative 8. And now I'm going to solve this equation for x. So I'm going to clear my parentheses first off. So 9 times 13, that's going to be 117, minus 9 times a negative 3x would be negative 27x, plus my 2x equals negative 8. So I'm going to keep going. I can combine negative 2x and a plus 2x. So 117 minus 25x equals negative 8. Solving for x, so I'm going to subtract 117 from both sides. So that gives me negative 25x equals negative 125 when I add those negatives. Continuing just to solve for x, so I'm dividing both sides by negative 25. So that gives me x equals 5. Okay, so I have part of my answer, and I'll come up here and I'll write, okay, I've got 5 for part of my ordered pair. And so I need to find the y part of my ordered pair. Well, what you do is you take the x part that you just found, and we're going to go up here, and we're going to use x in either one of these equations. Whichever one looks easier for you to work out, that's the equation I want you to choose. I'm going to choose the first equation. So y equals 13 minus 3 times, now I know x is 5. So we're going to work this out. 13 minus 15, so y is going to be equal to negative 2. So then negative 2 goes up here in my ordered pair. And so these two lines, if we were to graph them, would touch at 5, negative 2. And that's how you use substitution to solve these. Let's look at this next one. Now, the difference between number 2 and number 1 is neither one of my equations are solved for either x or y. So I'm going to look at them, and I'm going to choose an equation that has either a 1x or a 1y in it, and I'm going to use it. So this top equation has a 1x in it. So I'm going to take that and I'm going to solve it for x. So I would be subtracting 5y from both sides. So that gives me 8 minus 5y if I move that 5y over. Now I'm going to take 8 minus 5y, I'm going to box it in, I'm going to take it down here and I'm going to put it in for the x in the second equation. So I'm going to come out here next to it and I'm going to write 2, we're going to replace that x. Let me erase it. We're going to replace x with 8 minus 5y, still has the 2 in front of it, plus 6y equals 16. So now let's clear our parentheses. We're going to get 16 minus 10y plus 6y equals 16. So now I can combine like terms. 16, I've got a minus 10 and a plus 6. That's going to give me a negative 4y equals to 16. Now let's solve for y. I'm going to subtract 16 from both sides. So negative 4y equals 16 minus 16 is going to give me 0. That's okay, because if I take 0 divided by negative 4, I get 0. So that means over here in my y position, I'm going to have a 0. Be very careful, because on this one we were solving for y. So make sure that you put it in the y position in your ordered pair. Don't automatically put it in the x, because you need to pay attention to which variable you were solving for. Well, now that I know that 0 is y, I'm going to come up here to this next equation. I'm going to put 0 in for y so I can figure out x. So x equals 8 minus 5 times 0. Well, 5 times 0 is just going to be 0. So I've got 8 minus 0. So x equals 8. So I'm going to come up here and I'm going to put 8 up in my ordered pair. So 8, 0 would be my answer. That's where the two lines would touch. So 0 is okay to get an answer. In the last video, we talked about if you had parallel lines or lines that were on top of each other. In those cases, your x's and your y's would completely cancel out, and you would end up with an equation with a number equals a number. This is one where just the numbers canceled out. 0 is okay to get, because you know when we're graphing ordered pairs, we can graph a 0. Okay, let's look at the next one. I've got 4x plus 3y equals 3, and 4x minus y equals a 5. So again, I'm going to work with the equation that has a 1y or a 1x. In this case, it's a negative y, but that's okay. So I'm going to come up here and I'm going to have 4x minus y equals 5. So I'm going to solve this one for y, because I don't want to have to deal with fractions, and I'm sure you don't want to have to deal with fractions if you don't have to. So negative y equals, I'm just going to leave it 5 minus 4x. It doesn't matter if I've got it in descending order or not. But then everything has to get multiplied or divided by negative 1 on this one, because I don't want a negative y. So y equals negative 5 plus 4x when I divide everything by negative 1. Okay, so now I'm going to box this in. And this time it's going to go in the top equation, because I used the bottom equation for this first step. So that's going to go in for the y in the first equation. So I'm going to come up here and I'm going to have 4x plus 3 times my negative 5 plus 4x, this is what I'm substituting, equals 3. So let's solve for x. I'm going to distribute my 3, so I'm going to have minus 15, and I'm going to have a plus 12x equals 3. And so 4x plus 12x is going to give me 16x minus 15 equals 3. We're going to add 15 to both sides. So I'm going to get 16x equals 18. So I'm going to divide both sides by 16. So on this one, when I reduce that, that's going to be equal to 9 over 8. So I'm getting a fraction for the answer on this one, which is okay. Sometimes we may have to deal with fractions. I don't think that on Alex or on any of your homework that you're going to actually have a fraction. But let's just continue this one, because fraction practice is always good. You can always use some fraction practice. So now we need to figure out y. I'm going to use the second equation, and I'm going to put in my 4 times my 9 over 8 minus y equals 5. I'm going to multiply this out. So I'm going to cross cancel. 4 goes into itself once. 4 goes into 8 twice. So that's 9 over 2 minus y equals 5. I'm going to clear my fractions, because I don't like dealing with the fractions. So in order to clear fractions, you multiply everything by the denominator. So we'll multiply by 2. So that's going to give me 9 minus 2y, because those 2's cancel. 9 minus 2y equals 10. We're going to subtract 9 from both sides. So negative 2y equals 10 minus 9 would be 1. Divide by negative 2, so I get negative 1/2. So you can see that's going to go up here for y. There would be my answer. On this one, that would have been really difficult to be able to tell if I had graphed it that the intersection was at 9/8 and negative 1/2. That's why we need to have other methods of solving these systems besides just graphing. Okay, so it looks like down here on the bottom we're going to do some practice with what happens if all the x's and y's cancel. So again, in this top equation, I have it already solved for y, so I'm going to box that in, and I'm going to put that in for my y in my bottom equation. So 3x minus 3 minus 3x equals 1. So what happens with my x's? 3x minus 3x, they cancel each other out. So I have a negative 3 equals 1. Well, negative 3 doesn't equal to a 1, so that is a false statement. If you end up with a false statement, that means you have no solution. If I had ended up with a true statement, so let's just say if I had ended up with negative 3 equals negative 3, then I would have answered all real numbers. Sometimes they will call that infinite solutions. Either one means the same thing. So in this case, this example, it was a false statement, so that makes no solution. But sometimes you may have a true statement, so you need to watch for those. And you could have all real numbers or infinite solutions, depending on what the choice is to choose from for your answer. So that is solving systems with substitution.